Hi everyone, so in this video I'm going to go over some more independence examples. Now remember, independence is all about conditions and whether or not knowing a condition affects the probability of an event happening. So we would know one event happens first and then see if it affects the other one happening next. When those events don't affect each other, they are called independent events. If they affect each other, they are called dependent events. So that first event happening should not affect the second event happening in order for it to be independent. So there's actually an easy way to prove independence. If you remember back in geometry about similar triangles and how the sides were in proportion, they were similar. It's kind of the same idea with the table. Independence is really easy to solve for with a table because if the table is in proportion, then the events are independent and in proportion to one another. And if you remember from Ms. Tribby's video, there are formulas for this, one being the probability of B given A equals the probability of B. So you're more than welcome to use the formulas, but if those are slightly confusing, what you can do is this simple trick to figure out whether or not an event is independent. So the first question here says, based on the table above, two events are randomly selected. A student has asthma and a randomly selected student has a house who under smoke, independent. Justify your reasoning with appropriate probabilities. Now on the Regents exam, they actually don't even need to see the formula written. The only time you really need to know the formula is if they are giving you a question, a multiple choice, asking you like which one is correct. But the easiest way to see if events are independent is by just doing proportions with the table. And I'm going to show you several ones. You can do as many as you want, but you just need two fractions to see if they're equivalent. So one example is you could do 69 divided by 182. If the events are independent, then 473 divided by 755 would be equal. Also, these would be equal. 542 divided by 937. So let's just do this and then I'll show you another way you can prove independence. So I'm going to take my calculator, I'm going to divide these guys. So I have 69 divided by 182. I get 0.379. Let's see if that equals 473 divided by 755, and that's 0.626. And that automatically tells me they're independent. But you could have also done this one. 542 divided by 937, that gets you 0.578, also not equal. So you can do any combinations of two of these. It doesn't really matter as long as you're seeing that they're not equal. Now the other way you can do it is, if you notice I did like it horizontally, I did this divided by that and this divided by that and this divided by that, but you could also do it vertically. So you could also divide this by this, and this by this, and this by this, and this by this, and see if those are equal. Again, pairing two of them together. They're not going to be equal, just because I know that these weren't equal, so therefore these events are dependent. So knowing whether a person smokes in the house does affect whether or not a child has asthma. So that's the whole independence key, is whether or not an event happening first affects the event happening second. So that is the case here. All right, so let's do the next one. This one needs some help. We have to fill in the table. You can just simply do some math here. Like 1,000 minus 600 is 400. That'll help you get the 300 here. This will get you 750, which makes you have 250 here, and then 150. Okay, so we're going to do the same thing. I'll do it horizontal. Wait, did I do it? I did it horizontally before, so let me just double check. Yeah, so let's do it vertically. So if it says, based on the two-way table, does plan a vacation to New York and watching an ad online independent? So I could divide this by this, 300 divided by 400. And then I could also divide this by this, 750 divided by 1,000. Again, you only need two fractions, but as long as they're in the same area, I don't know if you can kind of visualize this. See how this is a rectangle, and this is on top of this. This is another rectangle, and this is on top of this. Same placement, kind of like similar triangles. Same placement in the table, just a different column. So I'm going to divide those in my calculator. So I'll do 300 divided by 400, and I will get 0.75, which does equal 0.75. So these would be an example of independent events. And you could also double check it if you want. You could do it like, I don't know, it really doesn't matter. You could do 100 divided by 250 and see if that equals 300 divided by 750. 100 divided by 250 is 0.4, and 300 divided by 750 is also 0.4. So these events are independent. Okay, and I know I've been neglecting the other column. You could also do this over that, and then this over that. Again, same placement. But anyways, because these events have the same decimals, therefore they are independent. So whether, like, knowing the event happening first, watching the ad online, does not affect them planning to vacation in New York, which makes sense because going to New York is a pretty popular vacation spot, so you really don't need an ad online to kind of persuade people to go there. So I hope that this helped you with figure out how to determine whether or not events are independent. Again, just try to figure out two fractions on the table in the same placement, and then see if they're equivalent to each other. I'm going to do one more in the homework, and then hopefully that helps you enough to do some on your own. So I'll do number 4 on the homework. I'll use the formulas, and I will also use the trick I just showed you. So with number 4, they're saying the two-way table gives about 200 random selected apartments in New York is the event that an apartment has a single occupant, independent, that it has a one-bedroom. So you could make this A prime, and this B prime, which is just denoting them. If you use the formula, I always like using the probability of A would equal the probability of A given B, meaning that if they're independent, this condition, this extra piece, would not affect the fraction. So the probability of A, here's A, how many people are in A? That's 76 out of 200. Now using the trick that I just showed you, 76 out of 200, that placement would either match 12 over 110 or 64 over 90. Now using the formula, I have A given B. So A given B. B is my condition, which means I'm only going to look at the B column. That's it. That's all I care about. So that means with the trick I just showed you, if this is 76 over 200, then we're going to use 64 over 90. Okay. So I'm going to divide that. So 76 divided by 200, which is 0.38. And we're going to do 64 over 90, which is 0.71 repeating. So I will say, therefore, they are dependent. And my conclusion would be, what are we talking about here? Apartments in New York City is the event that have a single apartment independent of the event that has one bedroom. So knowing whether or not someone has a single occupant does affect that it has an apartment that has one bedroom. So that is the conclusion of this problem. So I hope that this helped you, and I will talk to you soon.